So let's talk about simple harmonic motion. So I've got a lot of questions which I would like us to solve. The first question is a 0.50 kg block attached to a light spring oscillates on a frictionless horizontal table. The oscillation amplitude is 0.152 meters and the block moves at 3 meters per second as it passes through equilibrium at x is equal to 0. Part A, find the spring constant K. Part B, calculate the total energy of the spring. Then part C, find the block speed when x is equal to a over 2. Okay, so we have our data. Um, we have been given the amplitude to be equal to 0.125 meters. What else do we know? We also have the velocity, which is 3 meters per second. So the question is find the spring constant K. Now we are going to use the conservation of energy, where we say the mechanical energy is the summation of or the addition of the kinetic energy plus the elastic potential energy. Now if we have got the velocity, we have been told that the x is equal to 0. Okay, so if the x is equal to 0, we know that the mechanical energy is given by half Ka squared, kinetic energy is half mv squared, then elastic potential energy is half kx squared. So if x is equal to 0, we have been told that when it had the amplitude of 0.125 and it was moving at the velocity of 3 meters per second, then it was passing through equilibrium position, which x is equal to 0. So when x is equal to 0, the elastic potential energy is 0, so this has to be cancelled. So the only thing we're going to have right now is half Ka squared is equal to half mv squared. Our goal is to find K. We can see that we have got half both sides. We can cancel half, so we'll remain with K squared to be equal to mv squared. Our goal is to find the value of K. Let's divide both sides by a squared in short. So these two, they'll cancel. My K value will be equal to mv squared over a squared. We have the v, we have the m, and we also have the a. So let's go ahead and see the value of k. So k will be equal to, my m is 0.250, my v is 3 but it has to be squared, divided by the a 0.125, I square it. So my k value will be 0.250 times 3 squared, then I divide this by 0.125, then I square it. So I'm getting my k value to be 144 Newton per meter. That is my k value. So I'll put it here. The k value is 144 Newton per meter. As simple as that. So the SI unit for k is Newton per meter. If you want, you can do dimension analysis using this, where x is the displacement in meters, F is the force in Newton. So you want to find K. Using dimension analysis, you know that our K value will be Newton per meter. So that is it for part A. Now let's go to part B. Part B, we want to calculate the total energy of the spring. The total energy is the mechanical energy. So the mechanical energy is given by half Ka squared. So in this case, the K value is 144. The A we have been given 0.125. Now I have to square it. So what is the total energy? So when you hear the total energy, we are still talking about the mechanical energy. So 1 over 2 is 0.5 times 144 times 0.125, then I square it. So the total energy is 1.125 joules. That is my mechanical energy, or the total energy. Then the question continues, which is part C, is saying find the block speed when x is equal to a over 2. Find the block speed when x is equal to a over 2. Okay, Now we want to find the speed when x is equal to a over 2. So when we come up with any equation where there is x, we're going to replace it with what? We're going to replace it with a over 2. So I'll still use mechanical energy in this case. Okay, so I can use two methods if I want. The first one, I'm going to use the same mechanical energy, which is mechanical energy, like we said, is equal to the kinetic energy or the elastic potential energy plus the the, the kinetic energy. So we can see that we have half everywhere. We can cancel the half. So the Ka squared is equal to Kx plus half mv squared. Our goal is to find the velocity. Let's shift this to the other side. So we have Ka squared minus Kx squared will be equal to half, or in this case half has gone now, is equal to mv squared. Let's divide both sides by m, even here by m. So I'll have m and m will go, v squared will be equal to, in this case I can factor out k. So k will be a squared minus x squared, like that. I divide this by m. So meaning that I need to get the square root now. Okay? Meaning that v will be equal to plus or minus, or you can just say the square root of k, open brackets, a squared minus x squared, everything divided by m. But remember, we have been told that where there is x, replace it with a over 2. So it is the same as x will be equal to, my a is 0.125 divided by 2. So now my x is going to be 0.125 divided by 2. So my x is 0.0625 meters, like that. So let's replace now the values. So the square root of the k value is 144. The a is 0.125 minus, now it has to be squared, then we get minus 0.0625 also squared. I divide this by the mass 0.250. So what will be our final answer? Our v will be equal to, so I'll first deal with what is in the brackets, 0.125 squared minus 0.0625 squared. So the answer I get times 144. Then again the answer I get, I divide it by 0.250. Then I get the square root. So the answer I'm getting is let's see first. We have, so we're going to have 144 0. I'll just put the square root here. Then I'll say 144 open brackets 0.125 I squared minus 0.0625 I squared. So the answer I'm getting, I want to do times. Okay, let me just put it here. 0.011171875. Then I divide this by the mass, which is 0.25, like that. So my v will be equal to, if you want you can put plus or minus, so it's going to be 144, then 144 times 0.01171875. So this answer divided by 0.25. So I'm getting 13.5. Then I get the square root. Okay. So the answer I'm getting here is I'm getting 3.6. But let's first confirm this using another formula. I don't know if maybe my calculator is just having some issues. Okay, let me redo it. I'm saying 144 times 0 0.1 0.0117 1, then 875. Yeah, then I divide 0.25. I'm getting 6.25. Then the square root of this I'm getting again. So I'm getting different answers. I think my calculator is having some issues. So I think let me just do this. To make things simple, let me write this formula from here. But if your calculator is working well, I think you are supposed to get close to 1.5 meters per second. When you reach at this point, this is the same as, okay, when you reach at this point, this is the same as, you can say V is equal to, this formula can be written as the square root of K over M times this square now is going to be removed, A minus X, like that. Okay, now in this case our X is this one. So if you replace the K144, divide it by the M, which is 0.250, times, so I'm going to have my A value is 0.25, 0.125. So 0.125 minus, then I don't have space this side, let me just shift this here. My X value now is 0.0265. So we are saying 0. X is 0.125 divided by 2. Yeah, so I'm going to have 144, or first what I'm going to do is 144 divided by 0.250, then I get the square root. I'm getting 24. Okay, so it is 24, so meaning that my V will be equal to 24, then times what I'm going to have here is okay, I'm going to have 0. I'm going to have 0.125, 0.125 minus 0.0625. So again I'm getting 0.0625, like that. Okay, so if I multiply this 2 times 24, okay, yeah, I'm now getting 1.5 meters per second. So this is the answer for part C. Again, you can use another formula. Since we are dealing with X in this case, you can say, just direct, you say mechanical energy is equal to the elastic potential energy. The elastic potential energy. So half Ks squared is equal to half Kx squared. So where there is X, replace it with A over X. So you'll be able to get the same answer. So that is it for the first part. So we have question 2, which is saying a horizontal block spring system with the block on a frictionless surface has total mechanical energy E is equal to 47 joules, and the maximum displacement from equilibrium is equal to 0.24 meters. Under simple harmonic motion, when you hear to say the maximum displacement, we are talking about the amplitude. So in this case, the amplitude is 0.240 meters. That is the maximum displacement. So the first question is, what is the spring constant? So we want to find the spring constant. So how do we find the spring constant? Okay, so to find the spring constant, In this case, we know that we don't have the velocity. We have not been given the velocity. So we'll say the mechanical energy, the only energy which we have at this point is the mechanical energy is equal to the elastic potential energy, like that. So I'm going to say the mechanical energy is half kx squared, okay? Then the elastic potential energy is half kx squared, like that. And our goal is to find the the k value, and we've been given that the mechanical energy is 47 joules. So this value we have, so I'll just replace it with 47 joules. In fact, what I'm going to do from here, just direct, will say the mechanical energy, since we have been given, will have half kx squared, like that. Now in this case, this x is the same as the amplitude, which is 0.24. So when you stretch the spring reaching at the maximum position, x is equal to plus or minus a. So the mechanical energy is 47 joules, will be equal to half the k we don't know, the x we have 0.24. Now we square it. So I'll continue it from here. We'll have 47 will be equal to, what is 0.5? 0.5 is the same as half, then times 0.24. Now we square it. So I'm getting 0.0288k. I divide this by 0.0288. Even this side I'll divide it by, even this side I'll divide it by 0.0288. So these two will cancel out. So my k value will be equal to 47 divided by 0.0288. Okay, so my k value is, let me just redo it. So we have, okay, we have 0. I'll say 1 over 2 is 0.5 times 0.24, then I square it. So 0.0288. Okay, that's cool. So we'll say 47 divided by 0.0288. Okay, so the answer is 1631.1.9. So it's the same as, I can say, 1632 Newton per meter. That is my k value, and this k value is going to help me. I'll just put it here. I'll say my k value is 1632 Newton per meter. Now we can go to part B. So part B is saying, what is the energy of the system at the equilibrium position? What is the energy, or what is the kinetic energy of the system at equilibrium position? So using mechanical energy, everything is just coming from mechanical energy. Mechanical energy is given by the elastic potential energy plus the kinetic energy. Now we know that at equilibrium position, x is equal to 0. We don't expect to have elastic potential energy. So therefore, I'll say the mechanical energy will be equal to the kinetic energy. So I want to find the kinetic energy. So I'll say the mechanical energy we have been given already, that is 47 joules. So at equilibrium position, the kinetic energy is 47 joules. As simple as that. Okay, so that is it for part B. Now we go to part C. If the maximum speed of the block is 3.45 meters per second, what is its mass? So if the velocity is 3.45 meters per second, the question is, what is its mass? Okay, Now again, this is going to come from mechanical energy as well. So mechanical energy will do the same. We are talking about the speed at this point. If we have got the maximum speed, whenever you hear the maximum speed under simple harmonic motion, then you are at equilibrium position. At equilibrium position, x is equal to 0. The moment you hear maximum speed, then we are talking about at equilibrium position. So at equilibrium position, x is equal to 0, meaning that we don't have the elastic potential energy. So again, using this formula, I can clearly see that since we are talking about the maximum speed, x is equal to 0, I don't expect to have this. So I only have mechanical energy is equal to the kinetic energy. Now mechanical energy we have been given already, that is 47 joules. So I'll put 47, this is half mv squared. We have been given the velocity. Okay, so we'll say 47 is equal to half. The m I don't know, the velocity is 3.45. Now we square it. So what are we going to have? We are going to have 47 to be equal to, I'll have 0.5, which is 1 over 2 times 3.45, then I square it. So I'm getting 5.95. I'm not going to round it off, m. Then let's divide both sides by this 5.95125. Even here 5.92 or 5125. So these two cancel. Therefore my mass in this case is going to be 47 divided by 5.95125. So my answer is 7.895, which is just the same as 7.9 kgs. That is the mass. Okay, that is it for part C. Let's go to part D. So part D is saying what is the speed of the block when the displacement is 0.1160. What is the speed? Now they're asking about the speed. Again, at this point I'm going to use what? I'm going to use, since we've been given, we are saying that what is the speed? We want to find the displacement. Sorry, the speed, the velocity. So again, you use mechanical energy, the same formula. Mechanical energy is equal to the elastic potential energy plus the kinetic energy. So this mechanical energy we have already is 47 joules. But elastic potential energy is half kx squared. Then this is half mv squared. Now the best thing here to do is we can just to get rid of the fraction, do times 2 everywhere. So this is going to be 2 times 47. 2 times 47 is 94. So I have 94 is equal to k. Half is going to cancel out with 2 squared. Even here I'll have just mv squared. My goal is to find the speed. Okay, what I'm going to do is I'll shift this to the other side. So I'm going to have 94 minus k x squared is equal to mv squared. My goal is to find the v, make v as a subject of formula. I'll divide both sides by m, both sides by m. These two will cancel. V squared will be equal to 94 minus kx squared divided by mass. Okay, now let's plug in the values. So v squared will be equal to 94 minus the k value is 1600. I'll put them in brackets. 32 times the x, we have been told that the x is 0.160, so which is the same as just 0.160. Then I square it. Then I divide this by the mass. We discovered that the mass we found was 7 from question C. The mass we found was 7 since the mass is just constant, is 7.9. Okay, now let's see what we're going to have. So I'm going to have the v squared to be equal to 94 minus, so here I'll have 1632 times 0.160. 0.160, I square it. Okay, so I'm getting 41.7792. Then divide this by 7.9. So v squared will be equal to, now I'll just do it direct, 94 point, or 94 minus 41.7792, 94 minus 41.7792. So I'm getting on top there, I'm getting 52.2208. I divide this by 7.9. So now I'm getting 6.6. Okay, let me redo it again. So we are saying this part here, after I multiply these two, what are we getting? So we have 1000, 1600, 1632. Was our k correct? Just a minute. Okay, everything is okay. We were finding the k value and we say that it was 47 is equal to half k. The x was 0.24, like that. Now we square it. So we had, if I do times 2, is going to be 94 is equal to 0.24 k. Now this is squared, so I divide both sides by that, so it's 94 divided by 0.24, I square it. Okay, my k value was correct. Now we are saying 1632 times, I'm here now, I just want to make corrections here, times 0.160. Now I square it. Okay, I'm getting 41 point, okay, that is this, just okay. So 94 now minus 41.7792. So the answer I'm getting, I divide it by 7.9. So I'm getting 6.6 1022784. Now I need to get the square root. So if I get the square root of that, okay, if I get the square root of that, I should be able to get 2.5. So my velocity is 2.57 meters per second. That is my velocity. Okay, that is it for part D. Let's go to E. Find the kinetic energy of the block at x is equal to 0.16 meters. Now we want to find the kinetic energy. Now that we have the velocity, kinetic energy is going to be direct. Okay, so kinetic energy will be equal to half mv squared. So half, the mass is 7.9, the velocity is 2.57. Now we square it. What are we going to have? 0.5 times 7.9, then times 2.57, I square it. So I'm getting my kinetic energy to be 26.09. So my kinetic energy is 26.09 joules. That is my kinetic energy. Find the potential, that is F. Find the potential energy stored in the spring when x is equal to 0 point that. So one, just to find the potential energy. So the potential energy is half kx squared. So we have half, the k is 1632, then the x is 0.10 squared. So we have 0.5 times 1632 times 0.160 squared. So 20.889, which is the same as 20.9 20.9 joules. That is my kinetic energy. Let's go to the last one. So the last one is saying, suppose the same system is released from rest at x is equal to 0.24 meters on a rough surface so that it loses 14 joules by the time it reaches at its first turning point. Okay, after passing the equilibrium at x is equal to 0, what is its position at that point? They want us to find the x value. Now the total energy, we have been told that the total energy is 47 joules. Now the energy which was being lost is 14 joules, meaning that the energy which remained is 47 joules minus 14 joules. Okay, so what is 47 minus 14? That is 33. Okay, so that 33 joules, what we need to know is that okay, 47 minus 14, okay, 33. So we have 33 joules. 33 joules is the energy which remained. The energy which was being lost due to friction in that case is 14 joules. So the energy which remained was now 33 joules. Now the question is, what is its position at that point? So the energy which will have remained now is this. Now we want to find the position at that point. So you say the same thing. Now the total energy which we have, so the mechanical energy is half kx squared. We want to find the A in this case. Okay, so the A is going to be equal to the x. So I'll say the mechanical energy, now the energy which is remaining is 33. So half the k value will not change, 1632, then the A squared, like that. So we'll have 0.5 times 1632. Okay, so I have 33 is equal to 816. Okay, A squared. We divide both sides. I'll do it from here. I'm going to divide both sides. I have now this 816 A squared. Divide both sides by 816. Even here 816. So we'll have A squared to be equal to 33 divided by 816. That is 0.040441176, and then get the square root of this number. So our position at that point will be 0.20, just like that, meters. And this is making sense. When the energy was 47 joules, we had the x to be 0.24, but when the energy is now 33 joules, the x is now 0.2, which is making sense because 0.2 is just bit close to 0.4. Again, 33 joules is bit close to 47. So the x value, the position now is 0.20 meters, as simple as that. So that is it for this question.